Hi everyone, my name is Nana and this is my Project 3 presentation for design and manufacturing. Here are the 5 topics I'll be talking about. They're in the order of rolling, sustainable manufacturing, DFA, deep drawing, and injection molding. Let's get right into it. The first topic is rolling. This is the subset of metal working, which involves passing metals through rotating rolls to compress and elongate it. How does it work? So as you can see in the diagram, there are two parallel cylindrical rows which a metalwork piece passes through. This allows for plastic deformation of the metals and compresses and elongates the metals. There are 3 main categories, and they are cold rolling, warm rolling, and hot rolling. I've given example temperatures for steel in the brackets, but generally you can use any of the methods for depending on your use case. Let's delve deeper into the 3 categories. So cold rolling and hot rolling have their advantages and disadvantages. For cold rolling, no heating is required, and so you have higher dimensional precision because there is no expansion of the metal. You also get a pleasing finish since there is no expansion or heating of the metal. It does, however, have a high deformation resistance since the metal is harder to work with. For hot rolling, it's the opposite, where the metal is softer to work with and so you have improved workability. You also get enhanced material properties. However, there is lower dimensional precision since the metal expands, and because you have to heat it up, there are some energy requirements which also take up cost. Warm rolling generally gives you the best of both worlds. I chose to pick rolling as my first topic because 90% of all metal works produced by metal work operations are done by rolling. It's extremely versatile, and as you can see in the diagram on the right, it can be used to make rods, tubes, sheets, foils, pipes, and even H-beams from one singular slab, just using different rolling processes or using different shaped rolls. This allows you to mass produce uniform materials at a relatively low cost very quickly. The second topic I'm going to talk about is sustainable manufacturing, and this is the creation of products through economically and environmentally sound processes to minimize the negative impacts on manufacturing on the environment. There are a number of principles for sustainable manufacturing. They generally include recycling, using renewable energy, sustainable product design, and circular supply chains. I came to realize that most of these stem from sustainable product design, which involves taking your time to really think about the process and to make sure that you could potentially reuse product material, use renewable sources to power processes, or use resources for as long as possible. Here is a case study using Apple, for example, where they use sustainable manufacturing processes and sustainable design. So the Apple 2030 goal is the goal to have carbon neutrality across all their products. And they achieve this for the Apple Watch by using sustainable manufacturing and eliminating leather in favor of recycled textiles, using ocean transport to reduce transport emissions, and using fiber-based packaging instead of plastic packaging for their products. These are a couple of examples of how to achieve sustainable manufacturing through innovative ways. This topic is very important, and even big companies like Apple are now seeing the importance and urgency of having carbon neutrality. For a big company, you could see how such a step would go to impact the society at large, since so many people use Apple products. I picked sustainable manufacturing because climate change and resource scarcity are becoming more and more important topics with the world getting hotter. The benefit of this system is that you get cost savings due to the reduced waste. The only challenge might be the initial investments needed for sustainable technology, which may not be practical for smaller companies. The third topic I'm going to talk about is design for assembly, or DFA as is commonly known. DFA is the method of simplifying a product structure by reducing the number of components to increase ease of assembly. DFA involves a lot of things, but the overarching idea is to have fewer parts for repair ease and to make it easier for any robot or human being who is handling the product. So, having fewer parts in the product, for example, can reduce the manufacturing processes and assembly steps and make it easier for assembly. Mistake proofing can also make it easier for people to understand how to put the product together. Standardization can make it easier for repairs when something is needed, and ease of handling speaks for itself, where the user does not have to think too much about how to pick up the product. There's also things such as symmetry, built-in fasteners, and size, and these are all considerations which the engineer has to think about extensively in order to get the best experience for the person assembling the product. I picked this topic because assembly is a very key stage in the manufacturing process, and its strengths are that it reduces complexity and minimizes error. It saves time and it reduces labor costs due to simplifying the system. And this is big for a company, especially when they're mass producing. The only weaknesses might be that it requires advanced planning and it can limit design flexibility due to all the extra thinking and constraints on the number of parts. The fourth process I'm going to talk about is deep drawing, which is the process of forming a blank sheet metal into a cylindrical or box-shaped parts by punching the blank into a die cavity. So here's how it works. You have a punch right here, which comes down onto this blank piece, which is held by this binder. The binder is there to slow down the flow of the sheet while it's being drawn and prevent wrinkles from forming. After this, the punch pushes the blank sheet down into this cavity, which is called a die, and then the sheet is put into the shape of the die, making a cylindrical or a square piece. I want to point out that in pure deep drawing, there is no reduction of the sheet metal thickness, and there are a couple of variables that go into this, such as the punch speed, binder force, mechanical properties of the sheet metal, the corner radius of the punch die, and so on. The amount of force necessary for forming is increased up onto the lower dead center of the punch, and this is done to ensure that there is no expansion. There are some cases where expansion would be desired, however. I chose this process because there are so many applications for deep drawing, such as pots, pans, cans, tins, even kitchen sinks and automotive body parts, and they all use the same idea, just different shaped dies and different punching methods. The good thing about deep drawing is that you can produce high strength parts with minimal waste due to the precision, and it also scales well for high speed mass production, which is desirable for any company producing on a high scale. You can also get seamless, intricate shapes. However, these require precision dies, and as I mentioned before, there is a potential risk of material thinning, which may be bad for whatever process that you are doing. The last thing I'm going to talk about is injection molding. This is a process used to obtain molded parts by injecting molting material into a mold and then cooling and solidifying them. I'm going to talk about injection molding mainly pertaining to plastics. However, there are different processes that use different materials. So here is just an overview of how injection molding works. There are two main units, the clamping unit and the injection unit. As you can see, the injection unit takes in tiny pellets of plastic, heats them up into liquid form, and then pushes them into the mold, which is held by the clamping unit. The process is then repeated over and over again after having time to cool. I'm going to show the step-by-step process more. This is a breakdown of the previous slide. You can see there's clamping, injection of the liquid, dwelling, cooling of the liquid, opening the mold, and then removing the parts. And then the process starts all over again. I chose injection molding because for project 1 and project 2, both products that I designed used injection molding, and this just shows how versatile it is. It's used to produce any type of plastic part and used especially in the automotive, electronics, and consumer goods industry. You can scale for mass production with excellent precision despite its complexity, and you can also get a high level of detail. The only drawback might be, again, the initial cost of the mold and the energy for heating the mold, and this is generally something that you've seen throughout the presentation, but it's just an upfront cost and will not impact the long run. Here are the resources that I used in the presentation. Feel free to take a look at these if you want extra information. This video was used for educational purposes only. Thank you so much for watching and have a good day.